Hi, my name is Ryan Riddle, and I am doing option 4, salinity and freezing point for lab 1. In this experiment, I took 2 tubs, both filled with water. In one of the tubs, I had added salt water and mixed it until it had dissolved fully. And after I had mixed it and dissolved the salt fully, I put both of the tubs in the freezer side by side to make sure that they are both in the same temperature and that they are unbothered. Through the experiment, I had checked each tub about 15-30 minutes into the experiment, and I continued to check them out 15 to 30 minutes and reported when I had first seen one of the tubs turning to ice. The fresh water turned to ice much sooner than the salt water, and the fresh water had turned to ice about 45 minutes into the experiment, and the salt water took almost double that time. The salt water, when it started to freeze, it didn't freeze as one solid like the fresh water did. It froze as more of a slush, and in like pieces. It wasn't really one solid piece. And through this experiment, I had observed that with the addition of salt, the freezing point was lowered, and the fresh water had taken much longer time. This experiment kind of models how seawater and polar oceans freeze slower because of salt contents. Higher salinity lowers the freezing point, which makes salt water much harder to freeze, and you need a lower temperature than you would fresh water. And through this experiment, the main thing that I had learned was how salt water needed that lower temperature to really freeze and turn into more of a slush. And this explains why sea ice forms differently from freshwater ice, and the differences help explain how sea ice forms and why it matters for global climate and ecosystems.